This will provide a brief tutorial on how to generate simulated data from a model using Tetrad. So when you first open the program, you'll notice you have this blank workbench with a set of buttons at the left. The way to think about this is these buttons will allow you to create nodes in the workbench that will be useful for simulating this data. So you can click these buttons and then just drop them in. Now, for our purposes, we're going to need 4 of these nodes: a graph node, a parametric model node, an instantiated model node, and a data node. I'm going to go ahead and connect these using these arrows. Now, when you first drop these nodes into the workbench, they're gray. So that indicates that there's not any information kind of filled out for that node. So now that we've got our general setup constructed here, I'm going to go ahead and double-click on this graph node. So we've got a lot of flexibility, a lot of options to choose from, but the default, the directed acyclic graph, is what I want. That's probably going to be the most common for this course. And I'm going to choose an empty graph. So now I've got a page that's going to allow me to drop some variables in. So let's say that I'm interested in the relationship between watching television and a person's BMI. So that's the kind of data I want to simulate. And I'm also interested in how much people exercise and how much food they eat. So I'm just going to rename these variables according to the variables of interest. And then I can connect these nodes. I may need to save these and then return to this. So now I should be able to connect these nodes using this arrow. Now the way that you connect these nodes is going to be important, because here you're specifying the causal structure of the model that you'd like to simulate from. So in this graph, even though I haven't used any numbers yet, I'm specifying that I'd like exercise to depend on TV. And similarly, I want how much someone eats to depend on TV. And then I want BMI to only depend on these 2 variables. So I'm going to click Save. We've got several options again for the parametric model, but the SEM parametric model is fine for our purposes. And then here, at least for now, there's not going to be much to edit, so I'm going to go ahead and click Save. Oh, before I do, in this parameters dropdown, it's important that you can see these sort of error variables. Now, for our simulation, if we simulated without any error, then the data that we got out just wouldn't be really interesting at all, because there would be no variation. So for this simulation, it's important that each of these variables has sort of an error term that's also impacting it. And we can kind of be reminded of that by looking at those error terms. So it's just sort of a feature of the model to be aware of. So I'm going to click Save. And then next, I'm going to double-click on the instantiated model. Again, we've got several options. We can either choose a model which will standardize our variables to having a mean 0 and a variance of 1. I think I'll just go for the regular SEM instantiated model here. And then we've got some options about what parameters to choose. So these don't really matter because I'm going to go ahead and edit these in the node anyway. So I'm just going to go ahead and click OK. And then here you can see the strength of the relationship between each of these nodes. Now, if I want to edit this, I can double click and put in a new value. So in the back of your mind, when you're choosing these relationships, you need to think about what kind of variables you want your random variables to represent. or sort of how you're measuring them. So if we think of TV as being measured in hours, say, I might guess that an additional hour of TV might decrease the amount of exercise that someone gets by about, let's say, 0.1 hours, or maybe 0.2. Let's make this a little bit bigger. So I can specify that I want 0.2 here. Oh, you know what? I need to make this negative. I think that watching more TV will probably lead to less exercise. So here, I think someone will probably eat more calories with an additional hour of TV watched. So here, I'll specify, say, 40. And then similarly, I can specify the strength of the relationship I want between exercise and BMI. I think more exercise probably decreases BMI, so I'll say an additional hour of exercise is maybe losing 0.01 on the BMI scale. And in terms of calories, the effect on BMI is probably going to be quite small. So I'll say 0.001. Now, I've got some tabs to look a bit more about the implied relationships here based on the values that I've specified. So if you go to the tabular editor, we can see this organization characterizes which relationship we're talking about. So for these edge coefficients, these values measure the values that I've just put into the model. So you'll see that this 40 right here, say, corresponds to the node from TV to calories that I added just right here. And I could edit those here as well. So I could change this to, say, 35. And I can also change the features of the variables themselves, too. So I can specify a mean and standard deviation here. If this were a standardized model, all of these variables would have mean 0 and standard deviation 1. Now, if I were being really careful, I would need to choose mean values that make sense. So I wouldn't want, say, a negative value for BMI or negative values for calories or exercise for that matter. So here I'm going to choose values that I think roughly make sense. Say 0.5 for exercise. Oh, TV, I'll say 3 hours. Exercise, we said maybe 0.5. And then we've got some options about the standard deviation as well. So I'll say 2 and 1, maybe 2, and I think calories might have a standard deviation of 400. Okay, so then we've also got tabs to look at the implied relationships between these. So this will just report the implied covariance that my model is implying. So that's fine. So I'm going to go ahead and say save. Now, if I double click on the data tab, I can choose how much data I'd like to simulate from this model that I've established. So I'll say 2,000 observations. Click OK. And then now we can see this data that we've randomly generated. A small problem that you'll need to be aware of is unless you specify that you only want data that has positive values, some of these values might look sort of nonsensical. So I haven't constrained my data to being positive, so I'm getting negative values of exercise. So if I wanted to double click here, I can eliminate a node by highlighting it and then pressing backspace. So if I wanted to add another data node, I can connect it, double click. Then here I'm going to say, only give me positive data. And this time I'm going to generate 5,000 observations. And here we've got a set of data that we've generated from this graph that we originally specified. So that's it.